Hello, nieces and nephews. Welcome back to part 2 of our journey through the world of computer networks. From the last part, we gave a quick overview of this topic outline. We'll dive deeper into today. Okay, before we dive in, let's quickly revisit the objectives for this journey. You might recognize them from the last part video. Hiya, let's go. We start by defining a network. We then show how we can connect networks to create small internetworks. A network is the interconnection of a set of devices capable of communication. In this definition, a device can be a host and also can be a connecting device. In this part, we will focus on local area networks, wide area networks, and internetwork. Here, an isolated LAN in the past and today that you will see in picture A. LAN with a common cable is how LAN working in the past, and today we use LAN with a switch instead. A point-to-point WAN is worked by connect device network with connecting medium, and below you will see network topology types. It looks like religion symbols. Hiya, so scary. Networkism here. A switch WAN is worked by connect a switch network into another switch network with a connect medium. This is how an internet works that make of two LANs and one WAN work. And here is a figure of heterogeneous network made of WANs and LANs. Start with less than and two isolated LAN and have switch WAN connect modem to resident, and the isolated LAN use router to connect to switch WAN. An internet is a switch network in which a switch connects at least two links together. A switch needs to forward data from a link to another link when required. Here is a circuit switch network. In a circuit switch network, a dedicated connection called a circuit always available between the two end systems, and switch making it active or inactive. First case, fully used, and second case, 1/4. And here is a packet switch network. The most notable Internet is called the Internet and is composed of thousands of interconnected networks. Here is a figure of the Internet today. The Internet today is an internet network that allows any user to become part of it. The user, however, needs to be physically connected to an ISP. The physical connection is normally done through a point-to-point WAN. In this section, we briefly describe how this can happen. We have given the overview of the Internet structure. For communication to happen, we need both hardware and software. This is similar to a complex computation in which we need both a computer and a program. In the next section, we show how these combinations of hardware and software are coordinated with each other using protocol layering. A protocol defines the rules for communication between devices. When communication becomes complex, we use protocol layering to break down tasks into smaller parts. Each layer has specific functions that contribute to the overall communication process. Let us develop two simple scenarios to better understand the needs for protocol layering. Here is a single layer protocol. Here is a three-layer protocol. Protocol layering enables us to divide a complex task into several smaller and simpler tasks. It helps us separate the services from the implementation system, but it costs lower performance. And here is a logical connection between peer layers. TCP/IP is a protocol suite used in the Internet today. It is a hierarchical protocol made up of interactive modules, each of which provides a specific functionality. The term hierarchical means that each upper-level protocol is supported by the services provided by one or more lower-level protocols. The original TCP/IP protocol suite was defined as four software layers built upon the hardware. Today, however, TCP/IP is thought of as five-layer model. Here is all topics that we will talk about TCP/IP protocol suite. This is layers in the TCP/IP protocol suite. Start with application, transport, internet, network interface, and physical layer. Here is a communication through an internet. Here is a logical connections between layers in TCP/IP. Here is identical objects in the TCP/IP protocol suite. Here is a broader view of process of encapsulation and decapsulation. At the source host, we have encapsulation. At the destination host, we have decapsulation, while at the router we have the both. Addressing in the TCP/IP protocol suite. At the top, the application layer adds the message and names it. This is where your email client or web browser interacts. Next, the transport layer takes the message and packages it into a segment or user datagram. It adds port numbers to identify the specific application on the receiving end. The network layer takes the segment and wraps it in a datagram. It adds logical address to route the packet across networks. The data link layer takes the datagram and encapsulates it in a frame. It adds link layer address for communication within a specific network. Finally, the physical layer converts the frame into bits that can be transmitted over the physical medium. And this is multiplexing and demultiplexing. A is multiplexing at source, B is demultiplexing at destination. The OSI model, established in 1947, ISO is a multinational body dedicated to worldwide agreement on international standards. An ISO standard that covers all aspects of network communications is the Open Systems Interconnection model. It was first introduced in the late 1970s. This is a difference between TCP/IP and OSI model. The OSI model consists of 7 layers, and each layer has specific functions and responsibilities, while TCP/IP has 5 layers. So let's move to the topic Internet history. Now that we have given an overview of the Internet and its protocol, let us give a brief history of the Internet. This brief history makes it clear how the Internet has evolved from a private network to a global one in less than 40 years. There were some communication networks, such as telegraph and telephone networks. Before 1960, these networks were suitable for constant rate communication at that time, which means that after a connection was made between two users, the encoded message or voice could be exchanged. In 1972, Windsor and Bob Kahn, both of whom were part of the core ARPANET group, collaborated on what they called the Internet Thing Project. They wanted to link dissimilar networks so that a host on one network could communicate with a host on another. There were many problems to overcome: diverse packet sizes, diverse interfaces, and diverse transmission rates, as well as differing reliability requirements. Today, we witness a rapid growth both in the infrastructure and new applications. The Internet today is a set of peer networks that provide services to the whole world. What has made the Internet so popular is the invention of new applications. In the discussion of the Internet and its protocol, we often see a reference to a standard or administration entity. In this section, we introduce these standards and administration entities for those readers that are not familiar with them. The section can be skipped if the reader is familiar with them. An Internet standard is a thoroughly tested specification that is useful to and adhered to by those who work with the Internet. It is a formalized regulation that must be followed. There is a strict procedure by which a specification attains Internet standard status. A specification begins as an Internet draft. Here is Internet standards level. Start with maturity levels and requirement levels. Here is a figure of maturity levels of an RFC. The Internet, with its rules primarily in the research domain, has evolved and gained a broader user base with significant commercial activity. Various groups that coordinate Internet issues have guided discourse and development. Appendix D gives the addresses, email addresses, and telephone numbers for some of these groups. Here are acronyms for various organizations or concepts related to the governance and technical infrastructure of the Internet. These terms are often referred to as ISOC, IAB, IETF, IANA, and ICANN, and Network Information Center. Here is a figure of Internet administration. So we will take a quick summary of this journey. A Internet is a set of devices connected by communication links. A protocol is a set of rules that governs communication in protocol layering. The history of Internet working started with Alpha in the mid-1960s, and the Internet administration has evolved with the Internet. An Internet standard is a thoroughly tested specification. An Internet draft is a working document with no official status and a 6-month lifetime. Thank you all for joining me on the adventure through Chapter 1 Part 2. See you next time. Bye bye.